If you recall previously, we were working with the arithmetic mean, and that was taking the average of the sum of the numbers. But the geometric mean is also a very common type of average that we use. And the geometric mean states the following. If there are n numbers, the geometric mean of the numbers x1, x2, x3, and so on till x equals x sub n, the geometric mean of these numbers is x1 times x2 times x3 all the way to x sub n, the nth x, all of root n. Square root n. There you go. So that's the geometric mean, and it's a pretty powerful formula. And as you see, there's also a geometric concept that is quite useful in geometry problems, and we'll take a look at that. So basically, if we're given a problem like this, where we have a circle, and this line right here is the diameter. So this is the diameter. Say dia. This is the diameter. This line is the diameter, and this line comes at a chord perpendicular to the diameter. At this point, we'll just call D. We're given this length, which is 5. So we'll put a right angle. This length, which is 5, and this length is 3. And we're trying to find this length. The question mark is. And you can try to solve this problem using what we already know from previous tools, but it'll be quite hard. And using the geometric mean, we actually have an easy shortcut. Since we can just simply solve this problem using the geometric mean, plugging in 5 and 3. So the geometric mean of 5 and 3 will give us question mark. So we can do geometric mean of these numbers would be the numbers multiplied, taking the root of since there's two numbers, the second root, so 3 times 5, 15. So this question mark would be equal to the square root of 15. That would be this length. And now we'll work on a little more difficult problem. This one's from the AMC 10 or the AHJSME. So the question is asking if the arithmetic mean of two numbers is 6. So let's just stop right there and let's say the two numbers are a plus b. Arithmetic mean a plus b over 2 is 6, and their geometric mean is 10. So the geometric mean would be a times b, and since there's two numbers, we can just regular root is equal to 10. And an equation, so we're trying to find an equation with the given two numbers as roots. So these a plus b over 2 and a squared b are the roots. Now, Okay, so first of all, you can easily solve for a plus b. So a plus b will just be 12, since 2 times 6 is 12. And if you recall from Vieta's, for any equation, for any roots, so let's say we have x minus r times x minus s, this can be rewritten as x times x minus the sum, so r plus s, x squared for a quadratic, r plus s times x plus let me rewrite that a little better. The product of the two, so r times s. R times s. Okay, so since we know that for this equation we have a plus b equals 12, we must know that if we put this right in here, it should be negative 12x. So we can immediately eliminate this one, since it's not negative 12x. Eliminate this one. This one could be it. This one could be it. So we have C and D are possibly them, and not E either. Okay, so we need to use this equation over here. So solving for this, just take this, we just square it, and we get AB, square both sides, is equal to 100. And plugging in AB into RS, we know our value must be plus 100. So, writing this all neatly, we have x times x squared minus a plus b times x plus a times b. So we have a plus b equals 12, so we have x squared minus 12 times x plus a times b, which is 100. And getting rid of the parentheses, we got x squared minus 12x plus 100. And that is indeed what we have right at number D. And that's a brief overview of how you would use the geometric mean in a practice problem and the general form of its theorem or formula.